Mat 1033 Intermediate Algebra. This is Chapter 3, Section 1, Graphing Equations. I'm not going to do anything with the whiteboard because this is kind of just general information, information that you probably already know. I'm going to go over it and go over the example problems. I'm going to go from there. This starts on page 120. All right, first of all, what this is showing you here is a graph. Notice you have a y-axis and an x-axis. Notice that this isn't the kind of graph that we're going to do in algebra because this is really a bar graph. And over here you have what we call cycles. So, in terms of this, 2 to 11, 12 to 17, 18 to 24 are intervals that we have in terms of our math. We come over here, this is more of what we're going to do. This is the Cartesian coordinate system. Okay. And what you're used to graphing is just this axis here, which was a horizontal axis, where the right side was positive, the left side was negative. Okay. What happens is we now get this vertical axis coming up and down, and now this becomes positive x, this becomes negative x, this becomes positive y, this becomes negative y. In the middle here is the point origin, which is 0, 0. Make sure you understand that these are producing ordered pairs. This is quadrant 1, quadrant 2, quadrant 3, quadrant 4. You're not going to do a whole lot with the quadrants. The quadrants are important in terms of trigonometry and calculus. We come over here. Here's plotting some ordered pairs. This ordered pair is negative 2 for x, 5 for y. So we go negative 2 up 5. This is 5, negative 2. So here we go 5 to the right for x, down negative 2 for y. Your answers that you're going to have are going to be in terms of ordered pairs. They're going to be in terms of x written first, y written second. So anytime you deal with a problem, you have to solve for an ordered pair, your answer should be placed as an ordered pair as well. In this example problem here, this is example 1. All they're doing is plotting the points. And so A is 2, negative 1. You can see where we have this 2, negative 1 here. 0, 5. Now, I'm going to go ahead and mention this. This will come up later. Anytime we have 0 in the x position of an ordered pair, this is called a y-intercept. By the same reason, anytime we have a 0 in the y position of an ordered pair, this is an x-intercept. These are going to become very, very important. But you can see that the answers that they have here, they not only plotted the points on the graph, but they're telling you what quadrant they lie in. Make sure you understand that, as we go back up to the quadrants, the ordered pairs for quadrant 1 are always going to be a positive, comma, positive. The ordered pairs for quadrant 2 are going to be a negative, comma, positive. For quadrant 3 is going to be a negative, comma, negative. And then for quadrant 4 is going to be a positive, comma, negative. Talking about the numbers located in the positions. This is example 2. And what we're doing here is we're trying to determine if these three ordered pairs are a solution for this equation. Make sure you understand that if it's a solution for the equation, it's also a point on the graph. So what we do here is we have 0 for x, negative 12 for y. So we plug 0 in for x, negative 12 for y. We do the math. We find 12 equals 12, so it's true. Anytime we plug an ordered pair into an equation and we get the same number on both sides of the equal sign, it is a solution. It is a point on the graph. We do it for 1, 9. 1 for x, 9 for y. Plug it in, do the math. We get negative 6 equals 12, which is false. We do 2, negative 6. 2 for x, negative 6 for y. We solve. We get 12 equals 12. So we can see that 0, negative 12 and 2, negative 6 are solutions for the equation but also points on the graph. Now we're going into graphing equations. This is by using an input-output table. Make sure you understand that there are three names for x and y. X is considered a domain, an independent variable, or an input. Y is considered a range, a dependent variable, or an output. This is an input-output table. And basically what happens here is because we want to graph this equation, we have x's which we input. We pick these x's. What we then do is put these x's in the equation, solve, and we get our y. So this is the output. So x is the input, y is the output. So then all we do is we plot these points, which are 5, 3, 4, 0, 3, negative 3, 2, negative 6, 1, negative 1, 0, negative 12. On the graph, we get a straight line. Again, let me remind you, x is considered input, domain, independent variable. You may see any one of these three names for x in any type of problem. Y is output, range, dependent variable. Next we come to, they're mentioning standard form. They're using capital letters as a, B, and C. You'll see some books use lowercase letters. It's still the same, ax plus by equals c. Make sure you understand that what's about to come out is that they've just introduced standard form, ax plus by equals c. We're going to, later on in this chapter, in a different section, we're going to talk about slope-intercept form, y equals mx plus b. And then we're going to use point slope to solve equations. And if you look at point slope, that's y minus y1 equals m times x minus x1. Make sure you understand the connection between all three of these equations is that any one could be the other. You can use one to solve the other. Okay. Also, that all three equations, the x is to the first power, the y is to the first power, which means these are linear equations which will form straight lines. Here is a problem that we need to look at. It says your pay is $3,000 plus 20% or 1/5 of the price of the products you sell. So we get the equation y equals 3,000, which is your base salary, plus 1/5 of how many products you sell. We come over here, we can do an input-output table. Here we put 0 products sold, we get $3,000. If we sell 1,000 products, we'll get $3,200, 2,000, so on and so forth. So this would be an input-output table with x on the top, in the first row, and y in the second. As a matter of fact, in all mathematics, whenever you get data in rows, the first row is always considered to be x, the second row is always considered to be y. If we come to example 3, then what happens here is we're using the same equation to graph it. I don't know why they didn't put the 1/5 x in the front and then put the plus 3,000 in the back. That's the form that we should write. This is not in correct linear form. So if we were going to rewrite this, we would rewrite this in slope-intercept form, which would be y equals 1/5 x plus 3,000. So the questions say, if the salesperson sells $8,000 worth of products in a particular month, what is the salary of that month? B says that the salesperson wants to make more than $5,000 a month. What must be the amount of products they sell? So if we look at the graph, here's the first question. If you sell 8,000 worth of products, the products is on the x-axis, monthly salary is on the y. So if we take 8,000 and follow it up to the line and then follow over, we can see that the person's going to make $4,600 for that monthly salary. If the person wants to make over $5,000 a month, we work in reverse, coming from the y over to the line, come down, and we see that they must sell over $10,000 worth of products. So the ordered pairs are important because based on the fact that you have one number of your ordered pair, using the graph, you can get the second number of the ordered pair in any direction. All these problems left are just example problems of input-output tables. In terms of this, we have the equation y equals negative 2x plus 3. Because x is the first power and y is the first power, we know it's going to be a straight line. You can see here that they plug 0 in, they get 3 for y. They plug 2 in for x, they get negative 1. Plug negative 1, they get 5. They plot those 3 points. There's your line. There's your input-output table. There's your ordered pairs. There's your line. Make sure you remember, you really only need 2 points to draw a straight line. You come over here, make sure you understand in this problem here, even though it says y equals 1/3 x, I always like to put a plus 0 to indicate to myself that this is what the y-intercept is. So here's the y-intercept at 0, which is right here. My slope is 1/3, so if we're going to graph it by slope-intercept, I'd go up 1 and over 3, hit my second point, be done. We can see here that they plugged in 0, plugged in 6, plugged in negative 3, and they got their straight line. This is example 6. This is not a linear equation because one of the variables is to the second power. But again, you can see they picked their x's, plugged them in, got their y's, and plotted their points. Here again is another equation. This is an absolute value equation. And again, input-output table, they picked their x's, plugged them in, got their y's, and you can see it's a V shape. So this is what covers 3.1, and this is the basis for the beginning of the whole chapter.